All right, so y'all go ahead and do the factoring for today. And then once everyone has finished the factoring and the math knowledge, y'all can unpause the lesson video and you can check your answer with mine. So this is very similar to an x squared minus 26x minus 27 factoring, except instead of an x squared, we have an x to the 6th. And so we're going to use, instead of x, an x here, and we would normally have a minus 27 and a plus 1, we have to have a 3, because of x to the 3rd times x to the 3rd will give us this x to the 6th, and it'll also give us that x to the 3rd right there. However, this is not the complete factoring. Both this term and this term are sum and differences of cubes. So this first one will actually factor as x minus 3 times x squared plus 3x plus 9. And then the second one will factor, I'm going to write it below it because I won't have room next to it, x plus 1 times x squared minus x and then plus 1. And that's using your formulas for a cubed minus b cubed and a cubed plus b cubed, where you have a minus b, a squared plus ab plus b squared, and then you have a plus b, a squared minus ab plus b squared. You were supposed to learn those back 3 years ago, your freshman year. So if you have them memorized, then you should just be able to use that formula. So that's the factoring. All of this right here is your answer. Now for the math knowledge question. It talks about it, and then it says how many 6 plant packs of marigolds are in the greenhouse. Well, it told us that the number of petunias and marigolds were the same. So we can figure out the number of petunias here. We have no 1-pack plants, but we have 25 4-pack plants, so that's 100. And then we have 100 6-pack plants, so that's 600 for a total of 700. Now for the marigolds, we have 60 1-pack plants and we have 40 4-pack plants. So that gives us a total of 220. And we know that the 700 has to equal the 220 plus however many 6-pack plants that we have. And so if you solve that equation, you end up getting that x equals 80. And so D would be your answer there. All right, so moving on to the lesson for today. We're looking at lesson 67, area involving functions of y. So we've done finding the area under a curve throughout the year. These are going to be a little bit different because your equations are going to be set up different. So hopefully you'll understand the area involving functions of y after this lesson. So whenever you have x as a function of y, the input axis is going to be your x-axis and the output axis is going to be your x-axis. They're going to get switched. So sometimes, instead of having something like this, that's a parabola that looks like that. Well, that's a 3. We will have on this lesson something like that. We have x as a function of y because y is no longer y equals, it's x equals. And so this would be a parabola. It's going to start at 3 and it's going to open to the right. So those are the kinds of functions we'll be looking at today, the second one right here. So let's look at this example. Find the area of the region completely enclosed by the y-axis and the graph of x equals 1 minus y squared. So on these, you don't have to do a perfect graph, but it is very helpful to go ahead and sketch it just a little bit. So this is a parabola. If you need to, you can write it as negative y squared plus 1, if that helps you. But it's going to start at 1 here. And then since it's negative, it's going to open to the left. And so it's going to open this way here. And so that's a basic sketch of our graph. And it says to find the area completely enclosed by the y-axis and that graph. So that's going to be this area right here. All of that little area there. So now this one is going to be set up a little bit differently. Instead of using our x values, we're going to integrate negative y squared plus 1, and we're doing it with respect to y. So we need to find our y values here for our upper and lower limits. The way that you're going to find your upper and lower limits, figure out where this and this cross the x-axis, the y-axis. So if we're looking for our y values, where do those cross the y-axis? Well, that's going to be where the x value is 0. This right here, your x equals 0. So we can actually plug into our equation a 0 for our x, and we get negative y squared plus 1. So if you solve that, you would have y squared equals 1, and y would equal plus or minus 1. So this value here would be a negative 1, and this value here would be a positive 1. And so we're going to integrate from negative 1 to 1. So even though it's in y, you treat it the exact same as you would if it were an x. So we integrate, and we get negative 1/3 y cubed plus y, and then we're going to plug in from 1 to negative 1. So negative 1/3 1 cubed plus 1. We'll figure out what that is, and then we're going to subtract negative 1/3, plug in a negative 1 this time. So this is going to give us negative 1/3 plus 1, and then we're going to have minus. This is going to become a positive 1/3 minus 1. And then, if you keep going, you'll get a 2/3 minus a negative 2/3, which changes into a positive 2/3. And so you end up with 4/3 for your answer. And so that's the area between the y-axis and that parabola there. Okay, moving on to the next one. It says find the area of the region completely bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. So again, you want to start off by graphing it. This is a parabola. If you need to write it as x equals negative y squared plus 3, you can. So we're going to come over here to 3. Again, it's going to open to the left. Because it's a negative. And then we have y equals x minus 1. Well, it's going to cross at negative 1. And it's going to do something like this. Again, it's just a basic sketch. It's not going to have to be 100% accurate. You just need to get close so you can figure out what to integrate. So, just like we integrated two curves, you do whenever they were turned like this, when you had a graph here, then you had a graph here, you always did the upper one minus the lower one, the higher one minus the low one, to find the area in between the two curves. Well, now, for part of it, one is above and one is below. It kind of changes once you get over here. The area you're looking for is here, and it's kind of hard to tell sometimes which one's upper and which one's lower when they turn to the side. Well, what we are going to do is always do the one that's the furthest to the right minus the one that's the furthest to the left. And so that's going to be this parabola is to the right, and then we're going to subtract the line. It's further to the left. So when we integrate, we're going to have the parabola. So negative y squared plus 3 and minus the line. Now, I put dy. If I plug in x minus 1 here, I got a problem because that's not in terms of y. So how can I put my line in terms of y? Right, you just solve for x. X would equal y plus 1. And so now you have y plus 1. Now the only thing left to figure out are upper and lower limits. And the way that you're going to figure that out, you are looking for where they intersect, here and here. So we are looking for where those two equations are equal. So I know that x equals negative y squared plus 3, and it also equals y plus 1. So if I set them equal to each other, I can solve it by factoring. Or at least we hope it'll factor. Usually they will. And so this will factor. So plus 2 and a minus 1. So my y values are negative 2 and 1. So we go from negative 2 to 1. Now some people think it's easier to go ahead and combine your terms here before you actually integrate. I like to do that, but you don't have to do it. I just think it helps a little bit. I have negative y squared. If I distribute that negative to the y, I have negative y, and then that becomes 3 minus 1, so plus 2. Again, you don't have to do that. I just like to do it so that I don't have quite as many terms to integrate. So now if you integrate, you're going to end up with negative 1/3 y cubed minus 1/2 y squared plus 2y, and we're evaluating it from 1 to negative 2. Now we got to plug in our 1. So we're going to have negative 1/3 1 cubed minus 1/2 1 squared plus 2 times 1, and then minus negative 1/3 negative 2 cubed minus 1/2 negative 2 squared, and then plus 2 times negative 2. So this is going to be negative 1/3 and then minus 1/2 and then plus 2 minus, this would be a negative 8 times negative 1/3, so a positive 8/3, and then a 4 times negative 1/2, so negative 2, and then minus 4. And then if we combine our terms, we end up with negative, we can make this a 2 over 6, make this a 3 over 6, and then this one can be a 12 over 6. So negative 2 minus 3 plus 12 is going to be 7 over 6. And then minus, this right here would be a negative 6. And if we put it over 3, that's going to be a negative 18 over 3. So 8/3 minus 18/3 would be a negative 10/3. So make this a plus. And then we can make this 20 over 6. So that's going to be 27 over 6, which those both divide by 3 to give you 9 over 2. And so that would be your answer for that area. So again, whenever you're looking here, you're going to do the right minus the left, and then you integrate it. Now, it is possible if you accidentally had your functions backwards, you're going to get a negative 9/2. That's what you would have ended up with if you had integrated and you had done y plus 1 minus negative y squared plus 3. However, you can't have a negative for area, so if you end up with a negative answer, drop the negative. If you integrated it correctly, just drop the negative. Don't worry about going back and reworking the whole thing. If you know that you set it up, if you realize you set it up where you had your functions backwards, just drop the negative and move on. It's not something where you have to go back and completely rework the problem to get rid of that negative. Just drop it off because area is always positive. Alrighty, so your homework, you don't have any to omit, so you need to make sure to do that tomorrow so that we can go over it, and hope you have a good day.